Students, in today's session I am going to discuss about nomenclature. First video I had explained introduction part and functional groups also have listed. In this video what we are using terminology, where student is feeling difficult, where they are asking more questions. Based on that I am going to give some videos to you. With one video it's not possible to complete nomenclature, so upcoming days I am going to do more videos about nomenclature. Every video you can watch it and prepare notes and prepare well for the examination. So in today's video I am going to explain types of carbons and afterwards sigma bonds, and next one bondline representations. Okay, condensed form, bondline representation, expanded form, all these points I am going to discuss. Once completed I will give alpha, beta, gamma carbons also. Okay, first we'll go to the subject. First one, types of carbons. Types of carbons. It is very easy concept. Types of carbons. First one is, we have four types, students. First one is primary. Primary carbon. Primary carbon nothing but it is attached to only one carbon. Only one carbon. Look into this example. This it is attached to only one carbon. This is also primary. This is also primary. Now next look into the second one. What is that? Secondary carbon. Can you guess what is the definition here? Yes, secondary carbon nothing but it is attached to two carbons. Attached to two carbons. Two carbon atoms. Now I am going to write the structure C. Look into this. This is primary because it attached to only one carbon. This is also primary. What about this guy? This is secondary. This carbon attached to two carbons. Like that we are going to find out number of carbons in the given structure. Next one, tertiary. So can you guess what is the definition? Is it possible to give? Yes, tertiary carbons is nothing but, look into this. Tertiary carbon. It is attached to yes, three carbon atoms. Attached to three carbon atoms. See, look into the students, carbon, like this. Okay, now see, so give, what is this numbering? Is it primary or secondary? This is primary because attached to one carbon. This is primary. This is also primary. What about this guy? This is tertiary. That's it. Now, next look into the last one. What is that? Tertiary carbon atom. Completed. Now going to the quaternary carbon atom. Next one, quaternary carbon. Quaternary carbon. It is attached to four carbon atoms. Attached to four carbon atoms. Clear? Now I am going to draw the structure here. C. Yes, look into the students. Look into this. This is 1 degree. Primary we can represent it 1 degree. This is 1 degree. This is 1 degree. This is 1 degree. This is 4 degree. Like this. Okay. So secondary carbon atom you can represent 2 degree. This is 3 degree. This is 4 degree. What about the first one? That is primary. So we are going to learn like this. Now I am going to give some structures. Can you write? Yes, look into this. CH3, CH2, CH2, CH, CH3, CH2, okay, and C, 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 CH3. Here they are asking number of primary how many, secondary how many, tertiary how many, quaternary how many. So can you give the answer, students? Can you do? First you have to check it. All satisfied? See, carbon valency 4. Carbon valency 4. Hydrocarbons is nothing but only carbon and hydrogens. Okay, here 3 bonds, this is 1 bond, 4. This is here middle carbon, always you will get methylene group. Methylene group. CH4 is nothing but methane, right? CH3 linkage is nothing but we call it as methyl. Methyl. What about the CH2 group? Anyone have idea? CH2 group. CH2 group we call it as methylene. What we call it as methylene. See, one hydrogen differ also, complete name is changing. That's why while writing the structures we have to more alert. So here they had given structure, no problem, we can calculate. Sometimes they will give names, after that we are writing structures, and after that we are giving types of carbon. Students is missing marks, that's what I am telling. That example also will take it. Now this is, it attached to only one carbon, primary. Attached to, see, both the sides we have to check it, 2 degree. This is both the sides, 2 degree. Here 3 degree. This is 1 degree. This is attached to 2 again, 2 degree. See, look into this carbon, 4 quaternary. This is primary, this is primary, this is primary. Totally how many primaries? 1, 2, 3, 4, 5. So if methyl group is there, this is always primary. If methylene group is there, it is secondary. Okay, next only carbon is like this. This is quaternary. I am writing shortcuts here. Okay, so end group always methyl group, that is primary. Methylene group is nothing but definitely that is secondary. And 3 degree is nothing but CH like this. Okay, this is 3 degree. You can write like this. Now primary how many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Check it. 5. 2 degree methylene groups. 1, 2, 3. Yes, you can go for the shortcut also. What I gave shortcut? End group, methyl group, primary. 2 degree methylene group. And 3 degree CH group like this. And 4 degree means only carbon. Only carbon. Okay, little clear you can write. Easy shortcut. This is primary. And what about the this is 3 degree quaternary like this. Okay, now 3 degree how many students? Yes, 1. 4 degree also 1. Sometimes they may not give 4 degree, they may not give 3 degree. If it is not there, you can write 0. That's it. This is types of carbons. Okay, now next one, bond line representation. Some structures I am giving, they are asking you to write bond line representation. There also they are asking you to calculate primary, secondary, tertiary, quaternary, and even it hydrogens also. Okay, I am covering 2 questions here. Next question 2. CH3, CH3, CH2, CH3. This is the structure. This is the structure. In this structure, they are asking how many primary carbon atoms, carbons, and primary hydrogens also they are asking. Secondary carbons, secondary hydrogens, and 3 degree carbons, 3 degree hydrogens. Okay, now 4 degree carbons, 4 degree hydrogens. Okay, now look into this. This is primary, right? I can use another color. Primary. This is also end primary, easy. Now this is methylene group, 2 degree, very easy. This is 3 degree, right? That's it. Now primary carbon atoms, how many? 1, 2, 3. Primary hydrogens is nothing but primary carbon having hydrogens. 3 plus 3, 6, 6 plus 3, 9. That's it. And 2 degree, 1. How many hydrogens? 2. That's it. 3 degree, how many? 1. How many hydrogens? 1. Quaternary? 0. 0. That's it. Okay, like that. This is question 2. Next question 3. Bond line representation. Before going to write bond line representation, I am writing expanded form. Students, where student confusing expanded form only. After that, bond line representation. See, this same question I am taking here. This carbon having 3 hydrogens, I have written like this. And this carbon having 1 hydrogen, 1 methyl group. End. Always end you have to write methyl group. If methyl group in between you will get, that is wrong. Why? Because here carbon has 5 bonds, it will not exist. Right? Now next one, CH2. CH2, how you will write expanded form? Expanded form. H. Then last one, like this. Clear my point? This is what we call it as expanded form. This is what we call it as, students. Yes, expanded form. Expanded form. Now, they will give normal structure, they will ask you to write expanded form, or else they will give expanded form, they will ask you to write condensed form. This is condensed form. Above one is condensed form. This is condensed form. Okay. Now here they are asking you to calculate sigma bonds also. Sigma bonds. Now see, 1, 2, 3, 4, 5, sigma bond, single bond. See, down also, students, better to write. This is also expanded form. This carbon also you can write expanded form. That's it. Now calculate sigma bonds. So can you calculate? Yes, sigma, like this. Single bond we call it as sigma bond. We have learned, right? That's it. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sigma bonds and 0 pi bonds. How can you say CC single bond is there, only sigma bond. C double bond is there, C double bond C, 1 sigma 1 pi. 2 bonds means 1 sigma 1 pi. If 3 bonds is there, 1 sigma 2 pi bonds. After formation of sigma bond only pi bond formation possible. Next another type, this one. Here 2 sigma 2 pi bonds. That's it. Okay. Clear, students? Like this. At all single bonds, what is the hybridization? sp3. All, at least one side. Here, if you calculate this bond also, this is 2 sigma, you will get it. 2 sigma, 1 pi bond. Here, 2 sigma, 2 pi bonds. Here, 2 sigma, 2 pi bonds. Both the sides you can see, at least one side double bond, that is sp2. Both the sides you can see, at least one side triple bond, sp3. Here also Here, what is this? 1 second, students. Both the sides double bond, or else at least one side triple bond, that is sp hybridization. This is also sp. Both the sides double bond, CO2 example, ethane gas. Okay, see here, because this is very close to this structure, that's why we are giving sp hybridization. Number of sigma bonds, how many? 16 sigma, 0 pi bonds. But I am giving shortcut. This point already had explained in chemical bonding videos. Here also I am giving sigma bonds. How to calculate, students? Sigma bonds equal to number of carbon atoms minus 1 plus number of other atoms. Now, who is having good command in the chemical bonding chapter? This sigma bond hybridization topics feels very easy. Now calculate, students. Use the shortcut. Is it applicable or not? We can check it. Number of carbon atoms. How many? 1, 2, 3, 4, 5. 5 minus 1 plus other atoms. 3. Other atoms means hydrogens. 3. Here 4. 4, 3, 7. 7 to 9. 9, 3, 12. So tell me 5 minus 1. 4 plus 12. 5 minus 1, 4. 4 plus 12, 16. See, 16 sigma bonds we have got it. See, this is cross verification. It saves the time. That's the reason I gave shortcut to you. Clear, students? You can follow shortcut. This is not normal structures. This is normal structures only useful. Don't use ring-like structures. If you use ring-like structures, it is not applicable. Okay. Now, next one. Yes, this one I am giving homework question. Everybody do it. Check your knowledge, students. Check your knowledge. So here what is the question? This question you have to write primary carbon atoms, primary, secondary, tertiary and quaternary. So test yourself question I am giving, students. Everybody try it. You have to write first expanded form. How many 1 degree, 2 degree, 3 degree quaternary atoms are there? So give me answer. Comment the answer. If it is correct, no problem. Wrong also no problem. Next video I am going to give answer for this question. Okay. Now next one. Last one in today's session. So suppose one note points I am giving. Note points. What are note points? First one, bond line representation. Bond line representation. Bond line representation also, students, little confusing. 2-3 examples I can take it. After that remaining we can work out later. Suppose some structure they had given. What is the structure? Some 1, 2, 3, okay, 4, 5, 6. Some even number carbon, hexane. Actually its name is hexane. I will explain this nomenclature later. And hexane. This one bond line representation. How to write bond line? Bond line. See, bond is nothing but we are representing like this. That is only bond line representation between these two bonds. But see how to write 1, 2, 3, 4, 5, 6 carbons, right? See, 1, this is carbon 1, this is 2. I can use another color and make it easy. See, this is 1, this is 2, this is 3, this is 4, this is 5. 5 only I have written. Next one more. What is one more? This is 6. That's it. This is bond line representation. Bond line. This is between carbon-carbon bond. See students, always end is methyl groups. End always methyl group. In between carbon CH2, CH2, CH2. How many? 1, 2, 3, 4. 1, 2, 3, 4. You can check it like this. Can I give one more example? Okay, look into this. Some little tricky question I am picking. One, two, three, four. 1, 2, 3, 4, 5. 5 carbons is there. 5 carbons. How can you write bond line representation? And that too, second position and the third position we have substituents also. How to write? Check it. This is carbon 1. This is what students? Carbon 1. This is 2. This is 3. This is 4. This is 5. End always methyl groups. Okay, fine, completed. Now see, second position methyl group is there. You have to write like this. This is nothing but bond line representation. You no need to write a CH3 end, but to understand more better I have written here, that's it. And the third position is means this one. You can write. Finally, what is our structure? That's it. 1, 2, 3, 4, 5 carbon. This is the perfect. Like that we have to write bond line representations. Okay. Now, suppose they give next question. Sometimes they will give N-butane bond line representation. Butane means how many carbons, students? 1, 2, 3, 4 carbons. That's it. 1, 2, 3, 4. This is bond line representation. Is it clear? Now, next one. Today's topic, last one is alpha, beta, gamma. Sometimes we are representing node point, next node point, alpha carbon. Okay, next beta carbon. Next one, gamma carbon. Next, delta carbon. Alpha, beta, gamma. Delta. Okay, so this is with respect to functional groups we are speaking. With respect to functional group. With respect to functional group we are deciding. C, something they had given structure. So some functional group, OH functional groups they had given. Okay, this is skeleton. It has hydrogens, but you have to fill it hydrogens, or else no need. You can take just normal structure also, no problem. So here what I am trying to say, this is the functional group. With respect to this functional group, we are deciding the type of carbons. This is another question. This is the functional group. Functional group attached carbon. Functional group attached carbon, alpha carbon. Next carbon, beta carbon. Next carbon, gamma, delta. Here also, this is next carbon only, no? This side also same thing, beta, gamma. Here delta is not there, leave it. So I am writing functional group attached carbon. Functional group attached carbon, alpha. Next beta. Next gamma. Next delta. That's it. Not only functional group, sometimes they may give double bonds also, triple bonds also. With respect to that we can speak. Okay students, this is the next nomenclature part. Part 1 already have done. First you watch part 1, then come back to the part 2. Next many videos I am going to do. First year organic chemistry. All the videos you can see and get benefit. Definitely these are all useful videos. Where student is feeling more difficult, I am doing. Thank you students, thanks for watching. Please subscribe our channel, so share to your friends also, so let them get benefit. Thank you, thanks for watching once again.